Okay, let's go ahead and take a look at inverse trig functions. Now what we'll do is we'll start off with looking at the inverse trig functions before we actually get into the derivatives of the inverse trig functions, because it's important to understand the key concept behind the inverse trig functions first. So let's go ahead and first take a look at the original trig functions that we have. And we said that we have three basic trig functions, the sine and cosine, and then of course sine over cosine is going to be the tangent function. Then we introduced the reciprocal trig functions, which was the cosecant, the secant, and the cotangent. And notice that this is one way that you can go ahead and note both of those with respect to how we derive them from the original trig functions. And then we have what are called the inverse trig functions, and we're only going to be looking at the inverse trig functions for sine, cosine, and tangent. Now again, notice the difference in the notation in that the inverse trig function, the negative one is next to the sine, whereas for the reciprocal trig functions, the sign is in brackets and then the negative one exponent. So this right here is not referring to an exponent. It's the same notation that you use for the inverse functions. Now, in addition to having this notation here for our inverse trig functions, notice that you can also go ahead and talk about the inverse trig functions using the arc notation. So in other words, the inverse sine of x is exactly the same thing as the arc sine of x. Okay, and it's going to be the same for all of those. Now, the key concept, of course, is the relationship between functions and their inverses. Okay, in this case, we're talking about the trig functions and the inverse trig functions. With the trig function, you give a particular angle value, whether that's in degrees or in radians, and you produce a ratio of two sides of a right triangle. Now, what the inverse trig functions will do is they would, if you give a particular ratio, the output of an inverse trig function will be the angle that generated that ratio. So it's very consistent with any kind of inverse functions that we've dealt with in the past, and that we have a circular nature with regards to a function and its inverse. So let's just go ahead and take a look at a particular example here. Say, for example, if we have the inverse sine or the arc sine of 1/2. Now, the first thing that you got to think about is, what is that actually referring to? That's actually referring to a particular angle. So what we'll do is we'll just say that the angle then is going to be produced if we go ahead and say the inverse sine of 1/2. So what we can do then, in order to get a better idea of what we're dealing with, because I think we're a little bit more familiar with the regular trig functions, is that we can actually take the sine of both sides. So if we take the sine of both sides, we got the sine of theta is equal to the sine of the inverse sine of 1/2. And just remember, like when we dealt with inverse functions and functions, if you composite a function and an inverse function, the ending value that you come up with was the original value that you started with. So in other words, what we come up with then on this side here is just 1/2. So we know that the sine of theta is going to be 1/2, and we know, if we think about then about our unit circle, that we're coming out with the sine of theta being equal to 30. Okay? So what we're going to do then first in this particular section is we're going to be looking solely on this area right here. Now, there's another thing that we want to go ahead and do, and although this isn't in the textbook, this is going to be an important thing to be able to do later. So we're going to introduce it right now, and it's evaluating, say for example, the tangent of the arc cosine of the square root of 2 over 2 without a calculator. Now, how do you go about doing that? And it's the same process that we've just done. So if we go ahead and let theta be equal to the arc cosine of the square root of 2 over 2, because that's an angle, we can then go ahead and take the cosine of both sides, and we know that the cosine of theta is going to be the square root of 2 over 2. Now, if we go ahead and take a look at this relationship here, we know that that's going to be based upon a right triangle. So if we go ahead and draw our right triangle here, we know that theta is here, right triangle. This is the adjacent side. Oops. That is the adjacent side over the hypotenuse. So we have the triangle that is right here. So what we know then is, being that this is a right triangle, we can go ahead and use the Pythagorean theorem. And we know then that this, by doing all of this algebra here, that this value of x is going to be the square root of 2. So what that means then is that the tangent of the arc cosine of the square root of 2 over 2 is the same thing as the tangent of theta for this particular triangle. And if we know that, and since we know that the tangent is the opposite over the adjacent, and the opposite is going to be the square root of 2, the adjacent is the square root of 2, then we know that that value is just going to be 1. So we can go ahead and evaluate the tangent of the arc cosine of the square root of 2 over 2 as being 1. Okay, so again, just to focus, we wanted to, just to summarize, we want to go ahead and make sure that we understand the difference in the notation with the reciprocal trig functions, the inverse trig functions, and the dual way that you can actually go ahead and write inverse trig functions. The key concept again is how trig functions and inverse trig functions are related through the inverse relationship, and then and also keeping in mind that an inverse trig function, if you see it, is really referring to an angle. Given an angle, you can go ahead and establish a right triangle, find all the sides, and answer complicated questions that look like this, even without a calculator. Okay, so we'll go ahead and take a look at some of those questions, and then we'll go ahead and work on the inverse trig functions, evaluating them. And then in addition to that, we'll take a look at how to find the derivative of them as well. Okay, give it your best shot. See you later. Bye.